Hi guys, welcome to ARIVU channel. This is the Python series. In the last video, we have discussed what are operators, what are the types of operators. In the types of operators, we have discussed arithmetic, relational and logical operators. Now let's discuss the bitwise operators. What are bitwise operators? Bitwise operators are used to perform bitwise calculations on integers. Integers are also known as the decimal. Okay, the integers are first converted into binary values and then the operations are performed on bit by bit. That's why we can call it as bitwise operators. Then the result is returned in decimal format. So our inputs are integers and our output is integer. But in between, what happens? Operations are performed on binary bits. Okay, the next, the types of bitwise operators. There are 6 types of bitwise operators. Bitwise AND operator, bitwise OR operator, bitwise exclusive OR operator, bitwise complement operator, bitwise left shift operator, bitwise right shift operator. In this session, we will discuss bitwise AND, bitwise OR and bitwise exclusive OR. First, bitwise AND operator. So this is the bitwise AND operator table. If both the inputs are true only, we will get output as true. If any one of the input is false, means we will get output as false in bitwise AND operator. Got it? The next operator, bitwise OR operator. Here, if any one of the input is true, means we will get output as true. If both the inputs are false only, we will get output as false. We all know 0 represent the false and 1 represent the true Boolean values. Okay. The third operator, bitwise exclusive OR, caret symbol. This is the exclusive OR operator table. Here, if both the inputs are same, that means 0, 0 or 1, 1, we will get output as false. And if we have different inputs like 0, 1 or 1, 0, we will get output as true. Okay, let's take this example program. Here, I have created 3 variables A, B, C. I have given 10 to A, 7 to B. Here, in between A and B operands, we have the bitwise AND operator. So, we have to apply the bitwise AND operator table. So, bitwise AND operator table, did you remember? Now only we have discussed, if both the inputs are true only, we will get output as true. Okay. First, what happens? This integer will be converted into binary. So, what is it? This is the binary equivalent of integer value 10. And this is the binary equivalent of 7 decimal value. Okay. So, in between these operands, we have the bitwise AND operator. Now, we have to apply the bitwise AND operator table. Okay. So, here, both the inputs are true only, we will get output as true. If any one of the input is false, means we will get output as false only. Okay. So, first what we will get? The binary output. And then this binary will be converted into decimal. So, this is only our output. So, our inputs are decimal values, our output is decimal, but in between what happens, these decimal values will be converted into its equal binaries and the operations are performed on binary bits. Okay, and we will get the binary result only. That binary result again converted into the decimal value. Got it? Okay, let me execute this one. So, this is our result 2. Okay, so this is the decimal equivalent of this binary. We just try to use the inbuilt method, the binary value of 10 is, we have the inbuilt method, bin of 10. Okay, this is called the inbuilt method. With the help of this inbuilt method, we can find the binary equivalent of the given decimal value. Let me execute this one. So what is the binary value of 10? 1, 0, 1, 0. This one. This is the decimal. What is the binary equivalent of this decimal? 1, 0, 1, 0. Okay. So here 0b is prefixed. Okay. That means this is what? Binary number. Got it? Okay. So here we have, so all the processes are same, but you just apply the binary OR operator. Binary OR operator means if any one of the input is true, we will get output as true. Okay, this alone different. All the other processes are same, like the previous bitwise AND operator. Okay, so here this is the binary equivalent of decimal 10. This is the binary equivalent of decimal 4. And here I have used what? Binary OR operator. So you just apply the binary OR operator table here. So what is the result? 1, 1, 1, 0. This is what? The binary only. Again this binary will be converted into decimal. So we got 14 as output. Okay. And exclusive OR. All the processes are same. But what is the different? Here I have used the exclusive OR. So you have to use the exclusive OR, that is the EXOR table. So if both the inputs are same, we will get output as false. If we have the different inputs like 0, 1 or 1, 0, we will get output as true, isn't it? So here this is the binary equivalent of decimal 11 and this is the binary equivalent of decimal 7. In between these operands, I have used the exclusive OR and I apply the exclusive OR operator table values here, and this is the binary result. And this binary value converted into decimal. So this is our output. I hope you all understand up to this. If you have any doubt, drop the message on the comment section. In the next video, we will discuss the complement operator, bitwise left shift and bitwise right shift. Have a nice day. Thank you.